Welcome to Swamp, the Stream and Wetland Assessment Management Park in the Duke Forest of North Carolina. A restored urban stream and wetland complex dedicated to teaching and research and sustaining ecosystem services and functions on the landscape. Now let's take a tour of the various restoration phases in Swamp. We're actually in this parking lot right here. This is 751, that big curve. And so we're going to walk down this trail, which is 500,000 people go, and you're going to see a sign down here, the entrance to Swamp, which you have copies of everything. We're going to be looking at certain points on phase 1, and here's that curve we're talking about. This is the old stream channel. This is the actual contours for phase 1 that was designed by Baker. This is just the sponsors, and it simply says that Swamp will be coming in 0.2 of a mile. So technically you're not really in the swamp yet, you're in the upland part. What you've got is the before and the after, what the design looked like on this stream. And you can see what it looked like on the left versus the right. And you can see this cross vein that's in here. And essentially, we're going to lead towards phase 2, which is that way. And so this is one of the areas that we put in to show the stream. We can sample. You've got automatic samplers here to look at water quality. We do this on some storm events, and then we also do grab samples. So this was put in place for the public, but also we can use it, and we can use it for education and for research. So with that, I'll give it to Will.
So the only thing I'll mention is that this is the transition from the stream restoration project, which is upstream, and then the pond, which is downstream. And if you look upstream, you can just see the top of a rock structure called a cross vein. But the restoration project was completed before the dam went in. So that is actually a triple drop cross vein that were kind of temporary in the sense that we just needed them to hold the elevation until the lake went in. But if that ever fails, I guess you have this as a little nick point to keep a head cut from working up into the stream restoration project.
Monitoring, is this one of your wetlands?
Yes, these are across the way. These are one of the wetland areas. There are parts of the old channel are left as sort of turtle and amphibian habitat, and then also we get ducks that come back in here, and we also do vegetation plots. That's what those. That's where you saw some of the vegetation I talked about today. We monitor that, and Dr. Ho has been doing some of that vegetation analysis. We're going to go to the next site down, which is actually, this is actually the bird overlook, which you're going to see. It overlooks the stormwater pond or lake or reservoir or whatever. This is the next one down.
Well, so we've got quite a few birds in here. There's some mallards with their ducklings and some Canada geese sitting out here on the sandbar, but there's also a few spotted sandpipers utilizing the habitat here. And it's kind of interesting. It's kind of like, if you build it, they will come. We put this pond here and all these little micro habitats opened up. And the birds, as soon as there's a food source there, they're able to find it and utilize it. So we've had American bitterns come and make use of the crayfish population, or the cattails pop up. We get red-winged blackbirds coming in and nesting. So kind of interesting diversity of birds coming in and finding these habitats.
The sandbar here actually was not here when we first started. And it was just a little bit of one, and now the ridge, it comes here and it catches this edge, and it basically just puts sand pretty much every year. It's been building up, building up. It's creating almost a channel into the pond. What we do have, when we get over on the dam, we do have, if you see those white pipes, those are where the feldspar markers were. You see them out there too, but also where that far white pipe is and on the other side, we actually created about 20 meters by 10 meters, a 20-foot hole on each side. So that's for refuge, for fish, for amphibians. This is the stormwater pond. You pretty much can see this. You can see what it was before my talk, but essentially this is the sort of the view most people, the public, sees. The control structures are over here. And we got a problem from our last storm. We got logs that just came in, which we have to take off. This diagram shows you the general area starting up here, and there is a street up here at this end, 751 down at that end, and so essentially behind these houses we basically put in this natural channel design.
This is a pretty typical layout right here. You got a constructed riffle going into a grade control log J-hook, and then below that's a brush mattress with silky willow, silky dogwood, and elderberry probably, and then it either goes into a riffle with alluvium or maybe a log rock and roll kind of thing. And some of the meander beds had like 2 logs, log J-hook and then just a log vein, depending on just mixing it up some. And then some had root wise.
You can see we're going downhill here, which does help, but of course then you got to deal with, see there, I forget what size pipe came under the road there, but it was
Probably a 3-foot.
3-foot pipe. So that was your starting point, basically. It constrains you what's going here. And then of course we have one at the other end. So this was replanted. You can see some of the things coming in here. Basically this meanders down through to, goes under 751. The people here have been reasonably happy, and some of the people from these houses have come, which you'll notice, it's got houses all along this, but Duke owns this piece of property and this piece of property. So that allowed us the ability to come right into the urban setting and basically put this in right behind their houses, which is unusual because a lot of people own or think they own right up to the creek, but they don't. So we're trying to sustain these as naturally as possible. Obviously you have to put some stability into it. You have to put some rock structures. We did add pools and riffles. You can see log veins in here, but to cut down some and step this down. But this is a typical restoration for an urban system, and I think overall people are pretty happy with it. We have 2 sheets that we're going to pass around. One is actually the as-built for the actual phase 4 reach 1, and it was designed just to be a natural system channel design, but we did put in those low-tech aspects to this on this design. We'll pass this around and you can see what was put in there, and you'll also notice where it says constructed riffles, but also it says wetland flow control structure, which was just the pile of stones. So this can go around, pass it around. And then the second sheet I'll pass around is actually the overall design for this project, and it essentially shows you the actual anti-branching that was overlaid on top of, and with the design features, on top of the natural channel design. So just so you know what's coming around. So we'll go down in here.
So this is phase 4A, so our anti-branching wetlands. And you notice 2 things here. First of all, as Kurt was talking about, we have a box culvert coming under the road. There's a plunge pool, like we have it located with the other box culverts, that's sort of dissipating some of the energy of water coming through the back box culvert. And it's coming up here, and as it rises up, we have a split, the word anti-branching, the multiple flow paths. Some of the water is going down a channel with a natural channel design, and that is the channel going out to the left here that carries most of the base flow during low flow conditions. So the water is being diverted out of the stream channel into the anti-branching swale and down into the wetlands that we'll see in a few minutes. And as Kurt measured, we have mentioned we have a pressure transducer with a data logger here that's helping us measure the depth of water flowing over the weir, and we can use that to calculate the hydrologic flux into the wetland. And we have a storm sampler over there that's taking hourly samples for our water quality constituents, TN, TP, and suspended sediment. We can use those together to calculate mass fluxes. Is where our inflow swale is coming into our first, we were talking about a forebay that was capturing some of the sediment that's coming into the wetland system, and this is basically our forebay here, which is a little remnant of the original natural channel. It's been left, as we said, as a sediment trap essentially.
Well, part of the idea here is that we're going to try to let some of this grade naturally, and because we got this floodplain, to let this go. We are going to use these cells, but we're going to try to let some of this maintain itself naturally where we can. So let's move down. Neil's going down this way.
You can see we have some aluminum, big square aluminum stop logs that we're using, again, to raise and lower the weir and hold water back behind the structure. We have a metal track that's embedded in the concrete here, and we can slide our stop logs down into the metal track and then put the weir on top of it to do our water budget. Now, one thing we noticed is that when we first started putting this in place is that the weir board started to bow out just a little bit in the center, especially during really high flows. And so we took it back to a metal shop and had them weld on these aluminum tabs right here to basically keep the metal weir plate rigid in the center. And then using a little bit of bowl wax, toilet bowl, BOL bowl wax, and rubbing it along the seam between the weir plate and the top weir. And it's just a little bit of leak right here, but I can come back and just put some bowl wax on that. It does a pretty good job of sealing it off. So that's been pretty watertight for the most part.
That is the original Duke sewer line built in the 1920s. When Duke built the West Campus in 24 to 27, the city was broke and they had no money, so Duke was forced to pay for its own sewage treatment plant, and that's the pipe going to New Hope sewage plant, which is now closed. It's a park. Almost all of this land, almost every square inch, if you look at the old maps, was all farm, it was in tobacco, and it was all up for sale in the 30s pretty much because everyone was broke. It was all during the Depression, so the Duke family bought up thousands of acres of this land. Some of it is as little as 25 cents an acre.
I have had a love-hate relationship with beavers because we've had them, while I've modeled some of our restoration after them, we've also had some beavers come into part of our site and we've had to have them removed, and we fought with them, and so we sometimes we love them and sometimes we have to get rid of them.
If they come back, they'll stay. We had to take them out early on because we couldn't do our budgets. They actually did exactly what they're supposed to do, and that is they blocked the stream and put the water all over the floodplain, and we couldn't control where it was going. We couldn't measure it, although it was doing what it should be doing. But if they do it again in the future, we'll be fine with it. I can't think of any scenario that we really would affect too much, unless they block water off from the
Well, they
lake.
destabilize the channel, I guess.
Yeah, stabilize the channel. I think it's 5 or 6 parking lots off the campus. They're all tiled. It comes out underneath here, and that picture that I showed you is the area where the road was actually collapsing. They kept dumping stones. This is a big valley. Those were stabilized. Will's here he can mention what was done, but this was not a small task because there was a gully here that was some places 15 feet deep or more. So why don't you just explain to them what the design was, and then I'll talk about some of the features.
Yeah, so the design it's pretty standard. This was the Baker Greensboro office that designed it. You've got the 4-bay. There was nothing planted in this at all. It's just catching that water. And that smaller pipe, actually you get more water out of that one. It shoots out literally like a fire hose. So it comes in here, it goes through that's why there's so much trash on that rack, is it tops through that. And then you've got these 2 cells. They get bigger as you go down as the valley widened out. And you had a V-shaped valley. We widened it out. The extra dirt is obviously in that pile over there. The woody debris that was left over, because it was all wooded right up to the edge of the slope, is in that pile. And that woody debris will get used along with some of the fill when they redo the stream at the bottom.
Which is phase 5. That's the unfinished part.
Phase 5. So this goes into this cell. In each of the cells, there's a 4-bay. There's a low flow channel. There's a couple of pocket pools out there. It flows into the white pipe. So this one's perfect right now. It's flowing into that pipe. Goes down to the next cell. Same thing. It discharges into a small channel, which was the original channel. And we kind of, it's fairly steep at the bottom. But again, kind of like some of the other channels you saw, it meanders a little bit. There's some structures in there to stabilize it. And at the very end, it drops down pretty steeply through a riprap swale, because when phase 5 comes in, this is going to empty into a meander bend, right above a meander bend, and that'll be raised up when that priority 1 restoration goes in on the phase 5. So it's just a riprap swale to keep it stable, until that happens.
And we'll walk from here. Now, what I wanted was these wetland cells. They're planted in wetland species. I think there were 8 species that were planted here. We've already had geese here and some ducks. We've got to family of ducks in the lower one. It will be reforested on the upland. We'll have the wetland cells here, and then we are monitoring the, these was just put in, it's only been in not even a year for the plants, that this will be the first summer. So it'll probably fill in quite a bit when it gets to the first full summer. What we got is the forebay, the 2 wetland cells, and this is the stream reach, which is almost 5,000 feet, which has not been restored. But this is the lower end of the gradient. The first place we took you yesterday was up the road where you saw that huge gully. Well, this eventually comes down and starts getting narrower, but also not so deep, and it gets down to the end of 751 and hooks into the first phase. So phase 5 will hook into the first phase. So this section is a section we want to restore, but the temporary, and Will can tell you why we had to do, and he had to do this because we've got obviously a drop and we got some problems here.
Yeah, basically the existing channel came down and turned into a braided system that was, 8-9 feet deep in all the different little fingers or tribs. So all this water's here now. It was there, but it was a lot further down. The head cut came all the way back up in here, so we raised this up to make it a single thread channel, so it will tie in nicely with the main channel, and that's built. That's why it's so wet over here. It was wet before, but it was
nothing like this though.
Nothing like this. It was all incredible. I mean, you just disappear and then pop back up, disappear and come back up until you got down here.
That sheet going around shows you the steepness of the slope we had to deal with. But also, this is again, it's like those triple drop cross veins we put in on phase 1. We didn't know if the lake was going to be built. And it did get, so 2 of them are underwater. Here, this is put in to stop this cutting back, plus slowing down the water. And hopefully, Eddie and I, got too many wills. Eddie and I are we're working our tails off to get this last piece funded. We hope to have some success maybe by this summer and get this in place and get those piles removed so that my name's not mud with the president.